This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we're diving into the fascinating evolution of prompt engineering, a field that's rapidly reshaping how we interact with language models. It's a journey from simple queries to incredibly sophisticated techniques.
Indeed. The progress has been astonishing, moving from basic keyword searches to methods that allow us to fine-tune the behavior of incredibly complex models.
And it all started somewhere, right? Before neural networks, how did we even interact with language?
Think engrams and statistical models. Predicting the next word based on preceding words was a primitive form of prompting, though we didn't call it that then. Information retrieval systems relied heavily on keyword-based queries, requiring careful phrasing to get relevant results.
So the seeds of prompt engineering were sown long before the term itself existed. Let's explore that further. Let's start with the pre-neural network era. What were the limitations of those early systems?
The limitations were significant. Early language models, like engrams, lacked contextual understanding. They couldn't grasp the nuances of language, and information retrieval relied on simple keyword matching, often yielding irrelevant results. The 1960s and 70s saw early natural language interfaces, but these were rudimentary, with limited understanding of natural language. The 80s and 90s brought rule-based systems and more structured query languages, but these still lack the flexibility and sophistication of modern approaches.
So it was a very different landscape. The real revolution came with the rise of neural networks, didn't it? The period between 2010 and 2015 saw the neural network renaissance. What were the key advancements then?
This era saw the rise of word embeddings, like word-to-vec, which allowed us to represent words as vectors capturing semantic relationships. Sequence-to-sequence, C26 models, using RNNs, emerged, enabling machine translation by encoding input sentences into a vector representation and decoding it into an output sentence. LSTMs address the vanishing gradient problem in RNNs, improving long-term dependency handling. However, even these models struggled with long-range dependencies and maintaining context over extended sequences.
Right. So the stage was set for a major breakthrough, and that breakthrough arrived in 2015 with the transformer model and the attention mechanism. How did this change the game?
The attention mechanism was revolutionary. It allowed models to dynamically weigh the importance of different parts of the input sequence, enabling a far more nuanced understanding of context and long-range dependencies. This dramatically improved the interaction between the prompt and the model, allowing for more targeted and controlled generation. We could now direct the model's focus, influencing style, tone, and content with greater precision. Multi-head attention further enhanced this capability.
I see. It sounds like a significant leap forward in controllability and interpretability. Then came reinforcement learning in 2017. How did that impact prompt engineering?
Reinforcement learning added another layer of sophistication. We could now shape model behavior through reward functions, encouraging fluency, relevance, and mitigating exposure bias. Reward shaping allowed for fine-grained control over the generated text, enabling us to guide the model towards specific styles or tones. It also opened up avenues for addressing biases in language models by rewarding unbiased responses.
So we moved from simply providing input to actively shaping the model's learning process. 2018 brought BERT and the pre-training paradigm. What was the significance of that?
BERT was a game changer. Pre-training on massive datasets allowed models to learn powerful language representations that could then be fine-tuned for specific tasks. This transfer learning approach drastically reduced the need for large task-specific datasets, making prompt engineering more efficient and accessible. The masked language model (MLM) objective also opened up new possibilities for closed-style prompts.
And this led to a greater focus on task-specific prompt engineering. 2019 saw advancements in control codes and template-based generation. Can you elaborate?
Control codes allowed for more precise control over the generated text by specifying desired attributes like sentiment or formality. Template-based generation provided structured prompts with placeholders for dynamic content, ensuring consistent output formats. Reinforcement learning further enhanced controllability, allowing for more effective reward shaping and bias mitigation. Human-in-the-loop approaches also became more common, leveraging human feedback to refine model behavior.
So we were getting increasingly better at guiding the models towards specific outcomes. Then came the era of massive language models in 2020 and 2021, starting with GPT-3. How did that shift the landscape?
GPT-3 and similar models dramatically increased the scale and capabilities of language models. Prompt engineering became even more crucial in harnessing their power, as these models were capable of generating incredibly diverse and nuanced outputs. We saw a diversification of prompt formats, including instructions and role-playing scenarios, allowing for more creative and contextually appropriate generation. Domain adaptation and fine-tuning became more efficient, enabling quicker adaptation to specific domains. Ethical considerations, including bias mitigation, also gained prominence.
Right. The sheer scale of these models demanded more sophisticated prompt engineering techniques. Let's move to 2022 and beyond. What are some of the most advanced prompt techniques emerging now?
We're seeing a move towards multimodal prompting, combining text with images or other modalities. Multi-turn conversational prompting allows for more natural and engaging interactions. There's a growing emphasis on integrating domain-specific knowledge, making models more effective in specialized areas. Reinforcement learning with human feedback is refining models further, and techniques like contextual intent prediction are improving the accuracy and relevance of responses. Personalization and user modeling are also becoming increasingly important.
So the focus is shifting towards more interactive, context-aware, and personalized AI systems. Let's delve a little deeper into some of these advanced techniques. Chain of thought prompting, for example, has been quite influential.
Chain of thought, COT, prompting guides the model through a step-by-step reasoning process, making its thought process more transparent and improving accuracy on complex tasks. Automatic, auto COT, automates the generation of these reasoning chains. Self-consistency improves reasoning by generating multiple reasoning chains and selecting the most consistent answer. Logical COT, uses principles from symbolic logic to enhance reasoning and reduce errors. Tree of thoughts, TOT, and graph of thoughts move beyond linear reasoning, allowing for more flexible and human-like thought processes. System 2 attention, S2A, focuses on improving attention mechanisms to filter out irrelevant information. Thread of thought, THOT, handles chaotic contexts by breaking down information into manageable segments. Chain of table prompting is specifically designed for tabular data.
And what about techniques aimed at reducing hallucinations?
Retrieval augmented generation, RAG, integrates external knowledge sources to improve factual accuracy. React prompting interleaves reasoning and action, improving the handling of complex tasks. Chain of verification, COVE, incorporates a verification step to reduce errors. Chain of note, HUNTEN, improves the robustness of retrieval augmented models by carefully evaluating the relevance of retrieved information. Chain of knowledge, COK, systematically breaks down complex tasks into smaller, manageable steps.
The focus on reducing hallucinations is clearly a major theme. What about other areas?
Active prompting focuses on selecting the most informative examples for training. Automatic Prompt Engineer, APE, automates the process of prompt creation and selection. Automatic Reasoning and Tool Use, ART, integrates external tools to enhance reasoning capabilities. Contrastive Chain of Thought, CCOT, uses both correct and incorrect reasoning examples to improve learning. Emotion prompting incorporates emotional cues to enhance the model's understanding of effective signals. Techniques for code generation and execution include scratchpad prompting, program of thoughts, POT prompting, structured chain of thought, SCOT prompting, and chain of code, COC prompting. Optimization by prompting, OPRO, uses LLMs to optimize prompts themselves. Rephrase and respond, RAR, improves understanding by rephrasing user queries. Take a step back, prompting encourages abstraction and high-level reasoning.
Looking ahead, what are some of the key challenges and opportunities in prompt engineering?
One major challenge is ensuring fairness and mitigating biases. We need to develop better methods for evaluating models and ensuring that they are not perpetuating harmful stereotypes or inequalities. Another challenge is improving interpretability and explainability, making it easier to understand how models arrive at their conclusions. The increasing complexity of models and tasks also demands more sophisticated prompt engineering techniques. Opportunities lie in exploring hybrid approaches, combining different prompting techniques to leverage their strengths. Meta-learning and automated prompt engineering are also promising areas of research. The integration of prompt engineering with other AI techniques, such as reinforcement learning and knowledge graphs, will further enhance the capabilities of language models. And, of course, ethical considerations must remain paramount throughout the development and deployment of these systems.
It's a rapidly evolving field with both immense potential and significant responsibilities. This discussion has covered a lot of ground. What are your final thoughts on the trajectory of prompt engineering?
Prompt engineering has come a long way, and its importance will only continue to grow as language models become more powerful and sophisticated. The techniques we've discussed today represent just a snapshot of the current state of the art. We can expect to see even more innovative and powerful techniques emerge in the years to come, pushing the boundaries of what's possible with language models. However, responsible development and deployment are crucial to ensure that these powerful tools are used ethically and for the benefit of society.
Absolutely. The ethical considerations are paramount. This has been a truly insightful discussion. Thank you for sharing your expertise and providing such a comprehensive overview of the history and future of prompt engineering. It's clear that this field is not only rapidly advancing, but also carries significant implications for the future of AI.
Thank you for having me.
It's been a pleasure.